This video is over inequalities. So let's look at our number routine. Fix the mistake. It shows the equation is x divided by 5 equals 6. From what I can tell, to solve this person multiply both sides by negative 5, and so they got the answer negative 30. Let's go back and check his work. Where's my pen? So if I substitute the x with negative 30 divided by 5, that would be negative 6. So I know he did it completely wrong. I know why he did it wrong, because he did so he wants to isolate this variable x. In order to isolate the variable, you have to do the inverse operation. The inverse operation of divide 5 is multiply 5, not multiply by negative 5. So he should have, I'll rewrite it here, x divided by 5 equals 6. So he should have multiplied by 5, multiplied by 5. This cancels out, so x equals 30. To check your work, 30 divided by 5 is 6. Check mark. So today we're going to be learning inequalities. But before we teach that, this is a number line. What can you tell me about a number line? Well, a number line goes from least to greatest. The negative numbers are to the left, zeros in the middle, positive numbers are to the right. If I have two numbers like negative 5 and 1, which one would be greater? 1. So what can I say this? I can say negative 5 is less than 1, or I can say 1 is greater than negative 5. What if I had this or this? What can I say about the relationship between these two integers? I can say that negative 6 is less than negative 5, or negative 5 is more than negative 6, either one. So in today's lesson, you're going to be learning some key words for inequality lessons. You're going to see less than. The meaning is less than. Another way to say less than is fewer than. So an example is B is less than 16. Here is a hint of advice, because some people will see this inequality symbol and they get confused as to, so they'll see, where's my pen? They'll see this inequality symbol right here and they get confused on how to say it. So this is how I sometimes look at it. B and 16. 16 has 2 dots. B has 1 dot. And to make this inequality symbol, you connect the dot. So B has 1 dot, 16 has 2. So B has less than 16. That's how I see it. Or some people can just look at the symbol and know that B is, this side is less than 16. So let's show that on here. So can you give me some numbers that are less than 16? Which of these numbers would be less than 16? Would it be 8 or would it be 24? Well, 8 is less than 16. These numbers would be like, would 16 be less than 16? No. So to represent it on a number line, you draw an open dot. So you're saying that anything 16 is not less than 16. But all of these numbers, and do you see the arrow here? So let's draw an arrow. Anything less than 16. So for example, 15, 14, 13, 12, 11, 10, 9, 8. Those integers are less than 16. What about the rational number of 15 and 9/10? Would that be less than 16? Yes. So this open dot saying that not 16, but everything less than 16. Let's look at another example. So we have meaning less than, or equal to. It also could be using the word at most. That means it's the most it can be. So to show that m is less than or equal to 12. So let's show you why. 1 dot, 2 dot. So this side, m is less than 12 or equal to. So instead of doing a full equal, they just do 1 bar. M is less than or equal to 12. So m is less than 12. So which numbers here are less than 12? 11 is less than 12. 10 is less than 12. But this say equal to 12. So to show equal to 12, draw a closed dot showing that this is part of the group. And all of these numbers to the left-hand side, left of 12, are less than 12. So let's make sure this is correct. M has to be less than 12 or equal to 12. By highlighting this, are these numbers on this number line going to be less than 12 and equal to 12? Yes, it will be. Next example. Greater than. Whoops. Greater than or is more than. That means the same thing. So t has to be greater than 15. So here's t and 15. How do you know this is greater than? So to make the inequality symbol, this has 2 dot, 1 dot, so connect the dot. So this side is more than 15. So name some examples of numbers that are more than 15. 17, 18, 100, 200, 15 and 1/10, 19. So here's 15. So it's all of these numbers to the right of 15. Would it include 15 or not? T is more than 15. So 50, not 15, but it could be 15 and 1/10. So it's an open dot showing that it has to be numbers that are larger than 15. And our last example is meaning greater than or equal to, or at least. That means it's the least it can be. So it has to be higher than it. So A is greater than 57 or equal to 57. So if you need to, draw the 2 dot. This side is greater than this side, or this bar right here means equal to. So name some numbers that are greater than 57. 58, 59, 60, 61, 62, 63, or equal to 57. 57. So all of these numbers to the right are greater or equal to 57. But again, it does include 57 because it said equal to. So what you're going to be doing is you're going to be practicing. You are going to be so we're going to be practicing on this now. So I'm using some real world situation. Write an inequality that describes each real world situation. You may use any variable. Then I want you to graph the inequality. I'll use X for this one. Children under 6 ride free. So if you are under 6 years old, you may ride free. So I'll use C. These are children that have to be under 6. So name some ages that are under 6. 5, 4, 3, 2, 1. So it has to be under 6. So that means it has to be less than 6. Children has to be less than 6. So under 6 means less than 6. So let's graph this. This is up to 6 right here in the middle. This be 7. This be 8. This be 5. This 4. So which of these numbers are less than 6? 5 is less than 6. 4 is less than 6. So I highlight this. But then draw an arrow with this. But let's make sure. Is 4.5 less than 6? That's why I can highlight that. 5.5 is less than 6. What about 5.9? Is that less than 6? But can it be 6? No, it has to be less than 6. So would that be open dot or closed dot? It will be an open dot because I can't say 6, but I can say all the numbers that are to the left of 6 or less than 6. Next one. Children ride free through age 6. So they can be ride free through. That's up to age 6, through age 6. So let's see. So I mean, name some ages. A 1-year-old can ride free through age 6. Okay, that makes sense. A 4-year-old can ride free through age 6. Yeah, that makes sense. What about a 6-year-old? Can they ride through age 6? Yes, because it's like up to through age 6. So it is. So those numbers I gave you are all less than 6. So less than 6. But it could be equal to 6. So let's name it 6, 7, 8, 5, and 4. So all these ages that are less than 6, but equal, so I need to close it, including that, so equal to 6. Less than and equal to 6. Next one. You must be older than 12 to ride a go-kart. You have to be older than 12. So I'm going to use a different variable like P for a person. This person has to be older than 12. Does that mean less than or more than 12? It means more than. So 2 dots, 1 dot. So this side is more than 12. So name some ages that are older than 12. 13, 14, 17, 18, 19. But could 12 be part of it? No, 12 is not older than 12. So no, so it has to be, but 12.1. If you're 12 years and 1 day, are you older than 12? Yes. So 12, 13, 14, 11, 10, older than 12. So all of these are older, but it's not equal to anything, so open dot. And last but not least, you must be at least 48 inches to ride the roller coaster. That means the least you can be is 48 years old. So if someone is 50, sorry, not old is inches. Let's do it again. You must be at least 40 inches to ride a roller coaster. So if someone is 50 inches tall, could they ride a roller coaster? Yeah, because the least you could be, the minimum, the lowest number you could be is 48. So P has to be more than 48. But could you be equal to 48? You must be at least 48. If you are 48 inches, are you at least 48? Are you part of the 48? Yes, you are. So 48, 49, 50, 47, 46. So P is more than 48. So all of these numbers are more than 48, and it includes it, so equal. All right. So for the rest, you're going to be doing some independent practice. You're going to be given words or algebra or the graph, and then you will name the possible solutions. So let's do the first one. X is greater than 1. So I'll put X and 1. Greater than. So X is greater than 1. So this side is greater than this side. So I have my algebra representation. Let's graph it. 1, 2, 3, 0, -1. So it has to be more possible solution. It has to be more than 1, like 2, 3, and 4. So it has to be more than 1. Would it be an open dot or closed dot? Open dot, because it has to be, these numbers are more than 1. So 2, 3, 4. What about 1 and 110? Is that possible? Yes, it is. Our next one, algebra. A is less than -1. So A is less than -1. So let's graph it, -1. This is greater, so be 0, 1. This is less, -2, -3. So A has to be less than -1. Again, a number line goes from least to greater. greatest. So less has to be all of these numbers. So -3, -2 are less than -1. Can it be -1? Nope, it has to be less than that. Open dot. All right, what does this graph show? From what I can tell, it seems like the numbers are more than 12. X is more than 12. Wait, stop. More than 10. But does it equal 10? Well, it says the closeout is part of 10, so equal. So X is more than or equal to. If you wrote X is greater than or equal to 10, I'm okay with that. So name some possible solution. 10, 11, 12, 13, 14. Next example. B is, from in words, B is less than or equal to -4. So -4, -3, -2, -5, -6, least to greatest. B has to be less than or equal to -4. So all of these numbers are less than -4, but equal, so it has to be a closed dot. So -5, -6 are possible solutions. -10 will be possible solution. Next one, I'll use X because I like using X. All at least to greatest. All of these numbers are less than 21. Less. So 1 dot. This side is less than this one. So, yep, less than 21. But it's open dot. So is that including 21? No, it has to be less than 21. Like 20, 19, 18, 17, 16, and so on. So X is less than 21. M is less than or equal to 1.5, 1 divided by 10. M is less than or equal to 1 and 5 10. So that's my algebra representation. So 1 and 5 tenths, 2 and 5 tenths, 3 and 5 tenths, 0 and 5 tenths, -0 and 5 tenths. So less than, so least to greatest. So all these are least to greatest. And equal to, so close dot. And so 0 and 5, whoops, 0 and 5 tenths is less than, 0 is less than. Next one, P is more than or equal to 3. So P is greater than or equal to 3. So here's 3, 4, 5, 2, 1. It has to be more than 3. So all of these numbers are more than 3. And equal, so includes 3, so a closed dot. So 3, 4, 5 are possible solutions. X is less than -7. X is less than -7. So here's -7, -6, -5, -8, -9. Less than -7. So least to greatest. So all of these numbers are less than -7. Would it include -7? I don't see any equal, so open dot. So -8, -9 are possible solution. Least to greatest. So in this number line, the numbers are less than 50. X is less than 50, but it's a closeout, so it's equal. So X is less than or equal to 50, such as 49 and 48. And I think these are our last three examples. F is greater than or equal to -4. Here's F and here's -4. It has to be equal, so I know there's going to be a bar there. Has to be greater, so F is larger. 2 dots is greater than 1 dot, so F is greater. So let's graph this. -4, -3, -2, -5, -6. F, I know is equal, so this is part of it, so that's why I have a closed dot equal to the -4. And it's greater, least to greatest. So all of these numbers are greater, like -3 and -2. 1, 7. Next one, 4 and 5 tenths. 5 and 5 tenths. 6 and 5 tenths. 3 and 5 tenths. 2 and 5 tenths. Z is greater than 4 and 5 tenths. So it has to be greater than 4 and 5 tenths. So all of these numbers are greater than 4 and 5 tenths. Least to greatest. But it doesn't say anything about equal, open dot. So 5 and 5 tenths, 6 and 5 tenths. Oh, I should go back here and write -4 there. Gets equal to. And last but not least, x is least to greater than 26. But is it equal to? No. X is more than or greater than 26. And 27, 26 and 1/10. 30, 35, all greater. And that is the study of inequalities, how to model it. So using the word greater than, less than, greater than or equal to, less than or equal to. If it is equal to, it'll be represented by a closed dot. If it just said less than or greater than, it'll be open dot. And from what you know about a number line, it goes from least to greatest.